By now, we have designed a basic hierarchy for game classes using the object-oriented principles of inheritance, polymorphism, abstract classes, interfaces, encapsulation, and composition. Let us put everything together to see how this could transform itself into a real application. A design for an application should be represented using UML. UML, or Unified Modeling Language, is a general-purpose developmental modeling language in the field of software engineering that is intended to provide a standard way to visualize the design of an application. It has many types of diagrams that are used to represent the application design. Class diagram describes the structure of the system by showing the classes, their variables and methods, and the relationship among classes. There are notations to represent different aspects of the design. We have seen a lot of them throughout the course. This is a class diagram for a gaming application. We have an abstract game class with methods for start and quit. There is an abstract play method. Then there are subclasses of game like puzzle and board game. We have not designed the board game class yet. Let's do that now. Board game extends from the abstract game class. We are making board game also abstract because it is not specialized enough to be instantiated or played. Every board game must have a board, so to make sure at the start of a board game the proper board is assigned, we have defined an abstract method, assign board, which has a parameter board of type board. Board is an interface with methods to initialize, clear, and paint a board. The assign board method will accept an object of a class that implements the board interface. This is polymorphism. We have defined a tic-tac-toe board that implements the board interface. It is composed of tic-tac-toe tile objects. Tic-tac-toe tile class implements the tile interface and overrides methods paint and clear. Finally, there are specialized game classes, jigsaw, and word puzzle extending from puzzle. Chess, tic-tac-toe extending from board game. Board games must be assigned a board, so these classes will be composed of a board object of the corresponding type. They will have a play method where the logic for playing the game will be encapsulated. A concrete board class will encapsulate all the logic for initializing, painting, and clearing the board. A concrete tile class will encapsulate logic for painting and clearing a tile on the board. I know it's a little complicated, but that is how most applications will be designed. Going over the design in detail simplifies the actual implementation. Let us see the board game class. As already designed, this contains an abstract method, assign board, which accepts a board object. Finally, let's look at the tic-tac-toe class. It is a specialized game extending from board game. It has a variable for the board. In the constructor, an object of tic-tac-toe board is constructed and then passed to the assign board method. Assign board simply sets the board variable to the tic-tac-toe board objects. Finally, there is a play method inherited from the abstract class game. This will contain the logic for playing the game. We just have a message being displayed for now because we are trying to build the structure first. We will now test the whole thing, you know how, using a test class. In the main method, we create an object of tic-tac-toe and call the play method. Let's run it. It first calls the tic-tac-toe board constructor, then the tic-tac-toe tile constructor, initializes and displays the board. It then assigns the board and starts playing the tic-tac-toe game. Thus, we saw how all the components are designed and put to work together to build applications. Do attempt this on your own to get better clarity. You won't understand it fully unless you get your hands dirty.